Alright, welcome to the learning target number 6 video. Now this is going to be new, okay? This is going to be something that's probably going to be a little bit tricky. I'm just going to tell you that right now. May as well know going in that, you know what, this is probably going to be a little harder, but hopefully I can teach you it in a way that'll make things a little bit easier on you, okay? First of all, we got to understand something, and I need you to write this. I went over this a little bit, I think, in one of the videos I've done here. But a quadrilateral. Does anybody know what a quadrilateral is? It is just a four-sided polygon. She's got four sides. That's all it means. So that means it can be anything. It can be this. Some weird shape. It can be, it can be anything. Okay, it's just four sides. It doesn't have to be anything, any name. It can be some funky four-sided thing. Okay, and then a quadrilateral can be a parallelogram. I'm going to put p-gram. Now we know that a parallelogram has opposite sides congruent, and it has opposite sides parallel. Okay, so I'm going to go down now. A parallelogram. Hold on. Okay, a parallelogram. You know, a special type of parallelogram is a rectangle. Okay, as I was kind of giving you on one of those videos, I said something about, you know, a rectangle. You could technically call it a let me just zoom in here. Sorry, guys. Okay, a parallelogram, a special type of parallelogram is a rectangle. Okay, like I was trying to tell you when I was doing this, that's a rectangle. But I could also call it a parallelogram. I could also call it a quadrilateral, but it's kind of like I was saying in that last video there that, you know, when you guys, you know, I could refer to you as students or like human beings. I could say, hey, human, come here. Human, come here. And yeah, that technically is accurate for most of you, but, you know, you would rather be called by your name. And that's how rectangles are. Okay, and then a special type of rectangle then would become a square. So that's kind of how this works. Now I think you guys I know you've already seen this. You did this in 5th grade, so hopefully it's nothing new. But I have a feeling what I'm about to show you is something new. I hope it's not, but I have a feeling it is. Okay, that's kind of how that works. Now, there's one more type of special quadrilateral that we're going to talk about, and it is called, if my pen would work, I'm just going to draw like an arrow. You can do this a little bit better. It is called a trapezoid. Now, Mr. Edwards, he oftenly refers to the trapezoid as Uncle Trap. So if you see him in the hallway, ask him about Uncle Trap. He'll know what I'm talking about. Okay? The reason he calls it Uncle Trap is he says that he claims that, you know, everybody's kind of got that one weird uncle, and you guys know what I mean. Everybody's got that one strange uncle that's just different than everybody else. Well, that's kind of how the trapezoid is. It's a special kind of quadrilateral, but it's a lot different than these parallelograms and these rectangles. And a trapezoid looks like this. Move this over here. That's what a trapezoid looks like here. You guys check out my skills. Maybe. Oh yeah, I know. That's what you guys oftenly think a trapezoid looks like. Right? Now, if you're drawing it, just do your best, please, to draw it to the best of your abilities. Okay? And what a trapezoid is it's a quadrilateral, but instead of having opposite sides parallel, like this one did, this one had these opposite ones, but it also had these side ones also, right? All of them were parallel. Not with each other, but opposites. This one only has one set of parallel sides. That's it. These opposite ones here are not. So it's its own special weird person. It's a little bit different. That's why it's called Uncle Trap, because we all got the weird uncle that's a little bit different than anybody. That's kind of where that comes from. So that's very important to know this little, I'll call it a flow chart. I think you guys know what that is from Mrs. Godfrey's class. Okay? Now, I want to quickly, it says trace this on grid paper, blah, 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 but we're not going to do any of that. We might do it in class, but I'm more worried about you guys just seeing this. Okay, so I'm going to draw my line down through here. Okay. Now, there's a couple things you need to know. These two parallel sides, or the two sides that are parallel, there's only two that are parallel in the trapezoid. They are parallel, so go ahead and put your arrows. Remember, arrows just mean parallel. The little dashes mean congruent, but these don't necessarily have to be congruent. Matter of fact, they're not. Okay. We call these the bases. We have two bases in a trapezoid. Okay. We call them base 1 and base 2. Now, some people you might hear me say, or some others say, they might say base sub 1 or base sub 2, because that's like the little subscript is little, when it's below, it's a subscript like that. It's base 1 and base 2. Okay. So there's how you do that. And then you can see the height here. It still forms at a right angle with the bases, as you can see, both of them. But now, the way to remember the height with a trapezoid is just remember it as the distance, please write this, between the bases. It's just the distance between the two bases. Every trapezoid will have two bases. Every trapezoid. And that's what you're going to use to find your area. There's a whole long formula that I'm going to show you here in a minute. Okay? And there's what you see there. I mean, that's talking about a garden or something. I'm not really worried about that right now. Okay? Now, I'm going to quickly do this. You guys can just watch. You don't have to write anything. If I can get my pen to work, this is going to be awesome. Okay, so let's look at this, and I want to flip back and forth from here. Okay, the way this little activity is supposed to work, and like I said, we may do it in class, but I think you can watch and you're going to see it. You're gonna take another trapezoid that is identical to this one. So we're gonna make another one now, because I got all these things that allow me to do all kinds of things. I'm just gonna right click it, I'm gonna copy it, and I'm gonna paste it. Okay, so now I have two, as you can see. Okay, so there's my two trapezoids. Now, actually, before I do that, I'm actually gonna delete one of these. I'm gonna make this a little smaller. No need for it to be so large. But you can see that obviously there's my parallel sides, and then I don't know where it went. There it is. And there's my parallel side. So again, now I'll copy it. Dang it. That's not what I wanted to do. Sorry guys, I know this is brutal right now. Okay, there we go. Alright, so now I have this. Okay, now I'm going to flip back to my previous page, and you can kind of see where this is going. Okay, it wants you to tape the two together, so it has you flip it over. So I'm going to go ahead and do that. Okay, let me go back, let me go forward here. And I'm going to flip this thing over using my little tool here. Okay, there we go. A little more, there we go. And then I'm going to grab it and I'm going to bring it right over here. So you can see, hopefully you can see what's going on here. What have we created? A parallelogram. Okay. So, now, going back to this, we know that this right here was representing the height, right? So that means this would have been representing the height. Okay. We know that this one right here would be representing the base 1 or base sub 1, however you want to say it. This would be base 2. By the way, it doesn't matter which base is base 1 or 2. I usually just make the smaller one base 1. I don't know why, I just do. But obviously when we flip this thing over, now this is base 2 and this is base 1. Okay? Everybody clear on what I just did there? I took a trapezoid. I copied it and created the same trapezoid. I flipped it over, and then I just labeled all my things that was on there. Okay? Again, why this right here is base 1 and this is base 1 is because I took it and I turned it, remember, and that would be on the bottom now. Okay? So that's all I've done so far. Maybe you're starting to make connections already to what's going on. We know that we've created a parallelogram. right? We know that the area for a parallelogram is area equals base times height, which would mean this distance right here by this distance right here, right? Everybody agree with that? That would be the parallelogram. That's how you find area of a parallelogram. Forget that this line's here. I mean, I can take it out if you guys want me to. I can just get rid of it. And you can see what I'm doing here. I've just created a parallelogram with base and height. That's all it is. Only this length is not just base 1 or base 2. It would be the length of from in purple or blue or whatever color that is would be base 2 plus base 1, right? That's what the base is. That right there makes up the base of my parallelogram. The height's still the same. It's just the distance between the two bases. So that doesn't change. We get that from right there. Now, why am I telling you all this? Because, guys, you have just built the formula for the trapezoid. This trapezoid formula is very difficult to remember. Okay? It's a very hard one. It's one of those, again, I don't like using that word, memorize, but it really is what you have to do here. Now, you guys don't have to write in this because you watched. And it is in there. It's all in the notes, but I just want to do my own. And the formula's in there, so you don't have to write it. But I'm just going to write it just so I can stay on this page. Let me here. It's right here for you guys. Let me find it for you. It's right here. So it's maybe on like 2 pages from now. Okay, and it is 1/2 the height, 1/2 times the height, times the sum of base 1 plus base 2. Now, there's a reason that I did this. Watch. Darn it. Okay. Let's figure out all the pieces and parts of this thing. Let's figure out where all this came from. Because every single thing I just showed you has a reason why I showed you it. Okay, there we go. Alright. So, first of all, let's start with the 1/2. Let's start right there. Let's figure out where that even came from or why it's there or anything about it. Why is the 1/2 there? Well, think about it. We have we used 2 trapezoids to figure out that it was a parallelogram. Okay, so that's where this line comes in. But I'm going to get to that in a minute. Let's talk about the rest of it. Okay, this right here, the height. We're doing half the height. Sorry, that's so dark. Okay. What's the height? Well, we needed the height when we do the area of the parallelogram, right? So the height doesn't change. We're still multiplying by the height. Okay? And then the last part here, I will highlight in blue, is this parenthesis part. It's the base 1 plus base 2. And what does that represent? Well, that represents the base of my parallelogram. Remember, the base of this entire parallelogram is base 2 and base 1. That's how we got that base length. It was base 2 and base 1 put together, added together. Okay? So that's where it came from. So look where we build here. Again, this base 1 plus base 2 is the base of the parallelogram formula. The height is the height, doesn't change. It's just the height distance between the two bases. Okay? And then the 1/2 is just because when we do this, we don't care about the area of the whole thing. The whole entire parallelogram. We only care about this. Oh boy. We only care about this half, right? We only care about the area of that. So right there is why we multiply by half. Okay, now if I just blew everybody's mind, good. We'll talk more about it tomorrow. But it's kind of cool. I'm going to be honest with you. Up until about last year, I didn't even know where that formula came from. I knew the formula. I knew exactly how to use the formula. I could find the area of any trapezoid given, but I had no idea why that was the formula, and I didn't care, but it's actually kind of interesting. Okay? And I'm glad I learned it. So I'm going to skip all these parts because we might kind of do those in class, but we'll do this again. Okay? Let's get into like practicing actually finding some areas. Okay? So like here. So flip to page number 20. We're on 20 now. Sorry, I'm kind of all over the place on this one. Okay, here we have our trapezoid. Okay, and it gives us, now, real quick, what if this was 8 centimeters? Would that matter? No. We don't bother with any of these angled sides when we're doing area. Now, perimeter, obviously we'd need them. Okay. Now, it says here that TW, side TW, and UV are parallel. So they are the bases. I know that whatever my parallel sides are the bases. The bases are always parallel. Let's write that. The bases are always, it's a crazy W, parallel. Okay? The bases are always the parallel sides, and there's only one set of parallel sides in every trapezoid. Okay? So, you can see what they did here. I'm gonna set the formula up here. 1/2 times the height times parenthesis base 1 plus base 2. Okay? Let's see what we know. I would call this base 1. I would call this base 2. And then obviously the distance between the two bases would be my height. Okay? I know that this is 1/2 times my height of 14 times the quantity. What is that? 12 plus 26. And guys, I mean, this is the reason that we learned PEMDAS the whole year. I mean, everything we do builds on itself, as you guys have found out. I mean, everything we've done is just one thing leads kind of to the next, which is cool. So you never forget those things, or hopefully not. You got to do parentheses first. Okay? That's going to be 38. Okay? Now bring down everything you haven't used. Okay, remember a number touching a parentheses means multiply. Now we're done with parentheses. We don't have any exponents. We do multiplication or division, left to right. 1/2 times 14 is 7. 7 times 38 is going to be 266. Okay, now remember, we're doing area still. Centimeters squared. Okay, which is what we said it was. Okay? Okay. Here, let's practice on these. We got to figure out a base. We got to figure out a base 1 and a base 2 and a height. So I'm going to call this base 1. I'm going to call this base 2. And then I'm just going to use this right here as a height. Doesn't matter. I could have used it here. I could have used it here. I could have done it here. I could have done it here even. It doesn't matter. They're all the same length, okay? It's just all about coming right angles at both the base 1 and the base 2. Okay? And both of these are right angles. Okay, I know that base 1 is 1, 2, 3 units long. I know that base 2 is 1, 2, 3, 4, 5, 6, 7 units long. And I know the height is 1, 2, 3. So now we write the formula. Area equals 1/2 the height times the quantity, base 1 plus base 2. And we write the formula every time, guys. I will make you redo it if you don't. And I will count it wrong on a test if you don't. Okay? The reason I make people write it, people ask me why all the time. I make you write it because the more you write something, the more you're going to remember it. Okay? And you got to know the formula. Now, there are other strategies to finding the area. I'll show you those in later videos. Okay? Now, we're going to go ahead and start plugging in what we know. 1/2 times my height, which is 3, times 3 plus 7. Okay? Notice I did the first 2 steps here are very important, and I expect you to do the same. Okay? I expect you to write the formula, and then I expect you to do fill in anything for the variables. Remember when we did these, x plus 3, and then something over x plus 9 minus x, something like that, divided by 2, something like that. And I said when x equals 2. And I told you guys the first step here was to put these in parentheses. And then the second step was to rewrite it with that plugged in. Rewrite it so it'd be 2 plus 3 divided by 2, and so on. Well, this is no different, guys. It's the same thing. You're just plugging in your bases and your height into those places. So now you can kind of do it in one. You can follow your PEMDAS. Parentheses first 10. You know that you're doing 3 times 10 times 1/2. Okay? And that's going to give you 15 units squared. Okay, don't forget your units squared on there. Okay, this one here, I figure out what my bases are. Now, this is a little weird. Okay, this is where it gets a little bit more tricky. A lot of people go, oh, there's my bases. And I say, now, wait a minute. Are those parallel? Clearly not. okay? They're the parallel sides. Again, you guys think of the word base as the bottom of something, like the base of a TV is the bottom of it. That's not necessarily always the case, okay? The base is just the two parallel sides. So here we can see those are parallel. The base here is 3, the base here is 1, and then what's the distance between those bases? Right there, it is 4. So its area equals 1/2 the height times base 1 plus base 2. And I know you guys are going to get sick of writing it. I really don't care. It's going to help you remember it. 1/2 times 4 times 1 plus 3. Do parentheses first. That is 4. Okay. By the way, I just left that in parentheses right there. Just another way to show multiplication. 1/2 times 4 is 2. 2 times 4 would give me 8 units squared. Okay. I think we've done enough of those. Just real quick, what would be my bases here? My base would be here. My base would be here. Those are the two parallel sides. My base would be here. My base would be here. My height would be from the very top coming straight up or straight down at a 90-degree angle. Okay. So right there, and then probably I would pick like right there. Is probably how I would do this. Something like that. Okay? Let's go on the next page. And last two here. Last two, then we'll be done. Now we got actual heights on here. Now this one kind of gave it away because it gives it to you. But again, this would be base 1. This would be base 2. Okay? So again, these bases are not on the bottom and top like you're used to seeing like on this one here. They can be on the sides. It's just all about which two sides are parallel. So area equals 1/2 the height times base 1 plus base 2. And it's going to be 1/2 times 39 times 25 plus 13. Okay, and then get out your calculator. Actually, I want to do that parentheses first. It's going to be 38 times 39 times 1/2. Again, if you're okay with it, you can use 0.5 for your 1/2. 0.5 times 39 times 38. 741. Don't forget the label, though. We're doing area. Feet squared. I'd like you to quickly do this one here, number 12. Do it on your own, please. Okay? You know that this is your base 1, this is your base 2, and here's your height. Okay? I know that the formula is area equals 1/2 the height times base 1 plus base 2. Okay? Now we plug in 1/2 times 13 times 10.6 plus 21. Okay, this is going to give you 31.6, I think, times 13 times half, and there you go. Now you're ready to find the area, which is 0.5 times 13 times 31.6, bang, 205.4 centimeters squared. What does that mean? That means that there are 205 of these. 1 centimeter by 1 centimeter. There are 205 of them that'll fit in there. Then there is 4/10 of 1. So 4/10 of 1, which if you figure out what percent that is 40%. So that means imagine 40% of this. There's 40% of 1 more square. So there's between 205 and 206 of these in that trapezoid. Okay? All right, guys. That's it. See ya.